The next step will be the calculation of the source table for simple regression. Once again, we will see this in SPSS when we get to that point. There are three sources. There's the total, regression, that's what you have explained, and the residual, which in regression terms is your sum of squares error with that we refer to as within. So to get to the calculation, I'm going to create my source table. So source, sum of squares, degrees of freedom, mean square, f, and significance. We have regression, what's explained, the residual, and the total. We're predicting the values of variable y, so that is the source of our sums of squares in our regression model. So x predicts y. So the sum of squares total, I've already got it, is equal to the values of y minus the mean for y, all squared. So the sum of squares total is equal to the sum of those values. The sum of squares residual is simply the sum of squares total multiplied by r squared. As we said before, that's the coefficient of determination. It's the percentage of the total sum of squares that is explained by the relationship of y to x. So it is simply equal to the total sum of squares times by r squared. The residual is equal to the total sum of squares times by 1 minus the r squared. Okay. Another way to calculate the residual is to look at the difference between the actual value of y and the predicted value of y when we apply our regression model. So as you can see, our y-intercept is 15.4 and our slope function is 0.58. If I plug in the actual x, it'll give me a predicted y, which is referred to as y hat. The difference between the actual y and the predicted y is basically error of measurement, or error of our model. We just couldn't predict it, we're off. And then we square that. If you sum those up, it'll sum up to the sum of squares residual. So the first step is to calculate y hat. And it's equal to the slope. Let's do it right. That's equal to the y-intercept plus the slope function times by the value of x. And I'll make sure that when I drag it, I have it frozen on those values. So b14 plus the slope function times by the value of x for subject 1. And I do that for each of the subjects. Then the residual is equal to the actual y minus the predicted y from our regression equation, all squared. Now, if I've done this right, our residual should if I sum these up, it should equal 121.9. There's my 121.9. So we calculated, this to be clear, we calculated the residual two ways. We took the total sum of squares and multiplied it by 1 minus r squared. That's the first way we did it. And then the second way we did it, we calculated the predicted value of y, called y hat. Took the y actual and subtracted from it what the regression model predicted y should be for that value of, say, 30 in this case, and then squared it. And that was a residual. The next step is the degrees of freedom. The regression model uses, each equation in a regression model uses 1 degree of freedom. The total is n minus 1, and the residual is n minus 2. So in this case, 1 equal to 5 minus 2 equal to 5 minus 1. My mean square equals, divided by the degrees of freedom, my f observed equals mean square regression divided by the residual, and my significance equals to f distribution right tail, comma 1, comma 3. And as we can see, it's not the model is not a significant predictor. So in this case, the values of y, the x is not a significant predictor of variable y. Now, if we look at okay. Now, what we'll do now is I'm going to run this through SPSS and replicate what we have. I'm going to copy in our values into SPSS for our 5 subjects. And variable 1 I will call x, and variable 2 I'll call y. Analyze, regression, linear. My dependent variable is y. It's dependent upon the values of x. And then I click OK. And here's my output. So r squared 0.408, correlation of 0.639. My source table, 84.1, 121.9, and 206, degrees of freedom, and my significance. My slope function, 15.4, and my y-intercept, 15.4, and the slope function, 0.58. I also have my standardized coefficients. So the standardized one, it's simply, if I look here, 0.639. So that's based on the z-scores. And as you can see, in the simple regression, it's the correlation coefficient. And there is no y-intercept because it's 0, so that they don't bother reporting it. It gives me a t-observed for my, we'll get to that in another lecture. But there's my significance. So that's it for this, in terms of going through the source table and running through SPSS. Next will be simple regression diagnostics.